Hello students, the topic we discuss here is reciprocal lattice. If we have a crystal lattice which is existing in real space, then if we do a mathematical map from real space to Fourier space, then we get a reciprocal lattice. Now why we do this mapping? Because conveyance of information is well done in reciprocal space than in Fourier space, especially when we are dealing with the diffraction and similar things. Now, in real space, the units are meters or the units for distance. In Fourier space, units are 1 by distance, which means you can have 1 by meters unit. Now, you can see that the wave vector k is equal to 2 pi by lambda, and this is also in 1 by meters. So, a lot of things, especially when we discuss diffraction, is simplified when we use reciprocal space. And that's why this mapping is important. Now you can read this. Atoms are arranged in various sets of parallel planes because they have different orientations. Identifying these planes are difficult in real space, but when we go to reciprocal space, each of the point in reciprocal space represents a set of parallel planes, and therefore the discussion is simplified. You can read this. Now let's go to the mathematical definition of reciprocal lattice. So if we have A, B, C, these are the primitive lattice vectors which define real lattice, real space, real space lattice. Then A star, B star, and C star, and C star. These are the reciprocal lattice vectors which define reciprocal lattice. Now the mathematical definition of these are important from the exam point of view. A star is equal to 2 pi times. When we have A here, you will write B and C, B cross C in the numerator. In the denominator, you have A dot B cross C. B star, this is equal to 2 pi times. When you have B here, you will write C cross A. Denominator is same, A dot B cross C. C star is equal to 2 pi times A cross B divided by A dot B cross C. So denominator is same for all the three reciprocal lattice vectors. Now what is this denominator? It is actually the volume of the parallel epiped formed by A, B and C vectors. Now you might see a letter G, a vector G. This is actually translation vector in reciprocal space. And this is defined as G is equal to H A star plus K B star plus L C star. Now A star, B star, C star, their definitions are here. What are H, K and L? They are Miller indices. So let us discuss about it a little bit. In real space, the translation vector T is written as T is equal to N1A plus N2B plus N3C. So this was discussed in the previous video. Here N1, N2, N3, these are constants, and if they are integers, then the lattice is called Bravais lattice. Similarly, the translation vector in reciprocal lattice, it is given by G is equal to HA star plus KB star plus LC star. Now we are discussing about HK and L. So HK and L inside bracket, this is called Miller indices. and it represents the orientation of crystal planes. At what angles the planes are oriented, these indices will give you an idea. So how to get H, how to get K and L? It is given by this. H is given by small a divided by capital A, K is given by small b divided by capital B, and L is given by small c divided by capital C. Now what are these A, B and C? A, B and C are lattice vector lengths, and capital A, capital B and capital C, these are intercepts of the plane on these axes. So let us consider this example, then you will get the idea. So this is our A axis, this is the axis along B, this is the axis along C. Now since this is a cube, for simple cubic, we have A is equal to B is equal to C is equal to A. All of the lattice vector lengths are same. So we have this length is equal to A, this length, this is also equal to A, and this length, this is also equal to A. Now, what are the intercepts? Now, this plane is denoted by the Miller indices 2, 2, 1. How we obtained the Miller indices 2, 2, 1? So our H value, we got it to be equal to 2. K value, it is equal to 2. And L value is equal to 1. How we obtained this? So the equation was, for obtaining H, you have to put lattice vector length along A axis divided by capital A. This is equal to A divided by this capital A, it is the intercept along the A axis. So this is 1 by 2. The intercept is 1 by 2 here. The plane is cutting at 1 by 2 on the A axis. So actually it is A by 2. The plane is cutting at A by 2. Therefore this will become 2. Now K is equal to B divided by capital B, which is equal to, so here we have, this is our B axis. In the B axis, the plane is cutting at 1 by 2, and B value is also A by 2. This is also again 2. Now for L value, the plane is cutting at A. The plane is cutting at A, and we have to put the value of C because this is cubic. C is equal to A. So we put A at the numerator, and at the denominator we have capital C. Capital C is the intercept at C axis, which is A. So L is coming out to be equal to 1. Now suppose we get a fraction, like let's say you got HKL to be equal to 1 by 2, 1 by 3, 1 by 2. Then you cannot write it as fraction. You have to multiply with a common number and make it integers. So what I will do is multiply everything with a 6. Then I will get 6 by 2 is 3, 6 by 3 is 2, and 6 by 2 is 3. So remember this, when you write HKL finally, you have to write it in integers. So for that, you have to multiply by a common number. Now let us move on to solving a previous year question from CSIR NET exam. So here we have a hexagonal lattice, and the primitive lattice vectors are given A1 and A2. Lattice spacing is A equal to 1. We have to find out reciprocal lattice vectors. So here we are only given the diagram in which A1 and A2 are shown. We have to find out what they are. So A1 vector, what is it? We have to find out. To get the magnitude of vector A1, we can use the law of cosines. So what is law of cosines? If we have a triangle and we know the sides A and B and the angle between them, then we can find out the side length of C. C is equal to root of A square plus B square minus 2AB cos theta. This is the law of cosines. So if we use it here, we will get the magnitude of A1 to be equal to root of lattice spacing is given to be equal to 1. So A and B are equal to 1. 1 square. We are talking about this triangle. So we have 1 square plus 1 square minus 2 into 1 into 1. The angle, this angle, it is 120 degree because the lattice is hexagonal, cos 120 degree. This is coming out to be equal to root 3. Now we have obtained the magnitude of A1 vector. Let's write A1 vector now. Root 3 times. We have to multiply by x component and then add the y component. So x component is cos 30 degree times root 3 I cap plus y component is root 3 times sin 30 degree j cap. Therefore, this is coming out to be equal to 3 by 2 I cap plus root 3 by 2 j cap. So this is our A1 vector. Now A2 vector is also having the same magnitude root 3 and it is in the direction along y. Therefore, we can write A2 vector is equal to root 3 j cap. And to find the reciprocal lattice vectors, we need A3 also. So we take A3 is equal to k cap. A3 is along the z direction. Now, reciprocal lattice vectors A1 star, this is given by 2 pi times A2 cross A3 divided by A1 dot A2 cross A3. A2 star, this is given by 2 pi times A3 cross A1 divided by A1 dot A2 cross A3. Now it is only a matter of substitution. You have to put each of these vectors A2, A3, A1 and find out. Then you will find A1 star to be equal to 4 pi by 3 I cap. There is no j component. So option 1 and option 2, both of them have correct A1 star. There is no j component. The x component is 4 pi by 3. And when you find out A2 star, it will be minus 2 pi by 3 minus 2 pi by 3 I cap plus 2 pi by root 3 j cap. So this you can do yourself. Option 1 will be the correct answer.